dual band tape measure Yagi build, sanding the driven elements to bare metal and assembling the antenna. Hi guys, welcome back to the channel. So this is part 2 of the tape measure Yagi project. So all of these are now 3D printed because the filament has arrived and these have all been run off. The first 3 before the filament I had ran out, the remaining were all done with the new filament that I bought. So they're now all on this tube. So what I've got to do is I've got to put all the tape measure elements onto here. Now these have got covers that go with them. Whether these covers will work with these, I don't know. They've also got a hole in them, which the designers put in, that fits the coax cable, which I believe that's designed for RG58. I actually have some RG58 prepared and ready to go. Well, not quite ready to go, it needs the ends terminating. And if I'm not too much mistaken, yep, that's just going to slide straight through all of them. That's a nice comfy fit. The idea is that comes up onto where the tape measure is screwed in on the other side. I will need a hairpin match to match everything up, make sure it's matched to the 50 ohms that the radio is expecting. Well, it'll be 2 radios connected to this rather than through a diplex, because I don't have one of those. And also, that's pretty good for satellite work if you've got one radio for transmit and one radio for receive, because there's a lot of people out there that transmit and receive using the same radio on the satellites and can't hear themselves come back from the satellite, which with satellite operation you really need to do, and that's part of the things I want to use this antenna for. So the assembly will require me to screw some screws in, quite a lot of screws, and also put some ring terminals onto the end of this coax, because that's the only way it's going to go. I don't think I'd be able to solder it. How I'm going to connect it yet remains to be seen, but I may be able to connect it just by putting the wires on the screws without having to put the ring terminals on, but we'll see how we go from there. But I've got some ring terminals ready just in case, and I need to strip the end of that coax. So one of the first things I'll need to do is I'll need to find all of the driven elements, and I'll need to sand the ends off a bit so that there is actually somewhere for the coax to actually connect. So that'll be something I'm going to go off and do right now, and I shall return when I've done that. So I've got the end all sanded back. Oh, it's not focusing on that, there we go. And it doesn't have to be neat. So that's just exposing the metal underneath, because the paint will obviously act as an electrical insulator, which is not what we want here. So you can see that I've done it more or less on both sides. As long as you get most of the paint off, especially where the connection's going to be, you should be okay. I'm just trying to show you all of the ones I've done. There's all 4 of them, unless I've forgotten one, which, no, my luck, I probably have. So what I need to do next is attach those to the little plastic things on the tubes. So I'll have to take them off the tube so I can do that. So I'll just stop whilst I do that. Okay, so I've got everything mounted onto the boom now. It took me a week and a bit to do this, and I was also waiting for a 3D printed part, which I'll point out in a moment. The mounts are screwed onto the boom straight through the elements, as that's how those mounts are actually designed. So the spacings should be 5.8 inches between director 1 and director 2 of the 70sem side. Director 2 and director 3 should have a gap of 4.88 inches, that's between the centre, and 2.1 inches between the centre of director 3 and the driven elements, and 2.5 inches between the driven elements and the 70sem's reflector. So we look at the 2 meter side. That should be 12.5 inches between the centre of the director and the centre of the driven elements, and 8 inches between the centre of the driven elements to the centre of the reflector. That's the dimensions I've got here. Those may need tweaking, but that's the measurements I've got at the moment. We'll soon find out when we go on to the next video, which will be taking this outside and tuning it in an open space, because that's how you would have to tune it. Both driven element sides have got hairpin matches on them. I've also coiled some of the coax around the tube, because I think on the 70sem side I'm going to need a choke. Because when I was testing it indoors, I was picking up some common mode, and that's not ideal, so I will have to obviously tie that off if I think I need a choke there. Yep, and this is the 3D printed part that I was waiting 21 hours for. That's how long that took to print, because I had to set it for solid infill because it has to be, so it's nice and tough. Screwed onto the boom using very similar screws to the elements. I think these ones are actually slightly bigger screws, and it's screwed into the tripod, which will allow me to obviously tilt it and pan it around as the satellite that I'm using goes past. Because it's got the two separate feeders, this means what I can do is I can connect 2 separate radios to this rather than one radio. So I should, in theory, be able to hear myself come back from the satellite when I key up on the uplink side. So, for instance, the ISS repeater, that has an uplink on 2 meters and a downlink on 70 centimeters. So the 70sems radio would be used for listening, and the 2 meter side would be used for transmitting. Because it's primarily the ISS repeater and possibly SO50, because I think that's also a VHF uplink that I'll be using, it'll be more critical to get the VHF side of this tuned than it would be the UHF. But as long as both sides work, then that's all that matters, which is why we go and tune it outdoors in an open space. I will take it off the tripod to do that, and then obviously, because I've got to carry it down the stairs, which are just out there. And yeah, so that's the next video, will be the tuning. So if you like this one, you can give it a thumbs up. If you didn't, there's another button, and there'll be a video pop up on the screen momentarily that the algorithm thinks that you may like, but you might not like it. You can maybe buy me a coffee if you like, or send me a super thanks. That all goes back into the channel. Or you can become a channel member to get early access videos, or just a standard membership which just chips a little bit into the channel as well. So I've also taken delivery on the day of filming this of the Quansheng TK11. That is on my bench, ready to be done. There's also another video I want to do as well, which is on, you should be able to see that. I'll just grab it. Making one of these. This is a wire dipole centre that I've built out of a couple of binding posts and a 3D printed part. That 3D printed part is actually available for download on Thingiverse. So that's another upcoming video, as well as the next part of this tape measure antenna. So I will catch you in the next one. 7.3 for now, and I'm going to go off and get this finally put together because it's taken me a bit longer than I wanted. So catch you in the next one.